I think Dipanjan has covered most of it. Now that he has listed here, one of the important aspects in computing, writing a computing proposal is how much time. So that's very important. So the best practice would be that you have a small cluster at your own place. You work out, you try to see how much it is, and then use theoretical scaling to basically compute it. So I'm using a compute cluster in Germany, and I was just checking at the usage that I do for advanced. It is about 50,000 CPU hours. Okay, so it is 50 kilo CPU hours every month. Okay, so now that's almost on an average. The bundle of an average thing over the year is about 50 hours. So I think that is what is really required if you want to do hardcore simulations. And the Dipanjan mentioned about the queuing system. That is very, very important. And I mean, if you want to use supercomputer, you have to be very responsible. You can just not physically use it as your laptop or your desktop. Be very responsible in using it. But there's another important aspect because we are all kind of it is very bad when we are doing this. We are applying you cannot local install clusters. Now, all the good clusters basically follow this environment modules, which are essentially there. So there is this idea about module share. So essentially, if you want any module like Python or Visit or anything, it will not by default be there in your library. You have to basically call it. It will be there installed, but your environment has to be active. Okay. So don't install your own package in your own machine. That's not allowed. Okay. So you have to be very, very careful, responsible in using the clusters if the cluster access is given. I mean, there is these. I mean, of course, at your stage, perhaps you will not be able to apply anywhere. But you can collaborate, or if you go outside, for example, you are going to the Max Planck, go outside, you basically try to use these clusters. You have to use very, very carefully. You cannot basically just keep on running these things. And just don't basically run your simulations with largest number of nodes.
Just one more point. Please do not run your code on the head node.
Never.
Whether it's an institutional cluster or the cluster, you'll be kicked out. This is the problem.
So yeah, you definitely never. I mean, logging node is logging node. There is another important aspect. Usually, the storage. Okay, because most of your simulation has a lot of data. Now, what happens in these computing clusters is either you can ask for some storage already, so that they will be there, like always be there. $30. But usually, good clusters, if you store it in some Splash data file, after every month they will remove it. They will not even ask you. Okay, so if you don't take data, your data is gone. So big simulation kiya 1 mahine ka sab gaya. Everything will be gone. Okay, so it is very important that you also take care of your storage. Okay, so most of these computing computing proposals also require you to request how much storage space is required, approximate storage space. Okay, so apart from your CPU time, your storage space is also very important. Okay, and don't install anything on the head node, neither on the.
Yeah, also on the storage, there's something I'm not pointing it out. I listed out. So while you are proposing it and designing a simulation, it's absolutely critical for you to map out the storage, and you have to be judicious about it. For example, I'll give you again the Indian environment that we live in. In Ayuga, we have a 1 petabyte disk. 1 petabyte is unthinkable for us when you use international clusters. Here I get reports from us that 90% is used, please remove, and nobody is removing it. Why? Because it's people treat them like their own desktop. We do not have a crash policy. So in this kind of small scale system, you are more lax and you are pampered. But it happened to me. So I've run something, gone somewhere for Christmas, came back and saw my data has gone. Again, spend my CPU hours to rerun those models. Happens. But also more importantly, when you are running large scale production runs, you have large scale grid sizes. You cannot just dump a lot of data just for the sake of making movies. That is when we need a lot of data. Or if you want to analyze something at a much shorter frequency, use specialized scripts within in situ of the code. For example, Pluto has some analysis script. All the other codes will also have something similar. If you want to make something just for the plots, make slices. Modify your output structure. Again, that's why you need to go deep into the code and modify things. Modify your output structure so that it produces slices at one time. Because space is very important as well. And the thing is, they will remove it after 1 month. So you have 1 month's time to 1 month or 3 months, whatever it is, to get the data somewhere. What will you do? Where will you get the data? Will an institution provide 100 terabyte disk to you? No. 10 terabytes is also quite difficult, and it's on those portable disks which can break in the Indian somewhere.
So basically now modern supercomputers basically or these clusters have clouds. Okay, so you can actually also get access to those clouds. And so that cloud material will stay with you.
So there are storage like mass storage where you have on tapes you store the data. But the thing is, those kind of data is difficult to access for analysis. You have to load the data again on your spreadsheet, you have to do analysis and then push it back to the storage. So you have to be a bit careful with this.
And then sometimes clusters also have visualizations. So essentially, you don't need just your data can be there in your cluster itself, and you can do your own visualization there. For example, running transactions or can do visit over there. That's actually possible. So the idea is you don't have to bring your data. Then you have to also be careful that if you don't bring your data, goes into the data will be gone. So you have to be very, very careful. Okay, so all these things are very important. So writing a computing proposal is just not just writing a standard. And the scientific aspect should be highlighted. This stuff. Right, you should have peripheral knowledge of what you essentially want. And that is, remember, the experts are kind of evaluating that. So they would know exactly how much you are faking and how much it's actually the truth. Okay. So be very careful about this. Make all the filter. Even when you are using your normal programs, try to see what is doing. Use the core chart. We never go and see the concept word. Here written Intel Skylake. What is Intel Skylake? You should look into that. So that is what our working is. It's not just snacks, simulation, yeah. Occasionally, maybe they can have this Intel Xeon scalable. What is scalable processors? What are these processors? What are the technology that also you should be aware, because if you are aware of that technology, it will be easier for you to write it. Okay. So it is very important. You should be aware of the peripheral knowledge also. Just not doing alone science. Okay. So I think.
Wrap up any questions?
Any questions? Anything that you want?
General discussion. So any questions?
What is the head node?
What is a head node? The login. Very first login. So the EU structure is a login has a high memory node and also support multiple entries. But from there you submit. I show you a script with where I mentioned the number of cores, number of memories. That's called the bash VBS script or something. You submit the script and then login node then has a schedule that distributes the job in wherever it's possible depending on the queue of the system. So login is only for submitting the job, compiling and submitting. It is not correlated. Never. What happens is if you run, login usually has number of cores and high memory. If you run your system on it, it becomes very slow. People cannot access for it. They don't even log in. Exactly.
And then it is not very high number of cores also. It will be like modest cores, 30 to 64 core machine will be there. It will be not very high.
But this is a basic problem every new user of the HPC system makes. That because they're not aware of how things go. So before you go into a HPC and run things, please consult the user guide thoroughly and talk to experts who have already used. Okay, to understand how to go about it. Exactly.
And also now there will be hybrid CPU, GPU. So you also have to be very, very careful about how much GPU you ask, how much CPU you ask, and so on. All these aspects should be there. Any other questions?
Any questions? They take Christmas, but then give you more hours.
No,
There is a problem at
no. That will not happen. They have multiple team systems. So they will always have a kind of a backup of your data, right? All the time. So for example, if there is hard disk failure, so usually these big supercomputers, they always work on something called as a RAID mode. Okay, so they will always have a backup of anything. So that will not happen from that. I haven't experienced that any time.
No, but for example, if you're talking about downtimes of the first time,
They will have maintenance.
but they will not recommend you. And that's also happens for observational astronomy. You have a you get 7 nights on a telescope. You get a dark sky or
That is like
No, but
that's part of
but, I mean, maintenance, usually periodic maintenance are done. They inform you before only. Then don't run.
So flags for GPU also have the students mentioned explicitly.
class for GPU. Yes, sir. Any other those raised hand back? Yeah.
It's has server side some options. Is that what?
No, this is basically for certain visualization clusters have interacting node, meaning you can basically have like a virtual machine in front of you. You can just basically open. It's just a Linux terminal open for you, and you basically can just
Interactive mode means you can do an SSH X.
So you can do all sorts of things.
Exponent GUI and then so you can reserve that node, login node, that compute node, not login node. And then use that compute node for your analysis for a certain duration.
And the smooth part is that it will always connect to your data, so you can just directly get it.
there is a small scale clusters which can be very common.
Usually small scale. What is small scale?
Like a Google Color, these people, you have that.
You run it on the cloud. Cloud, yeah. And that's available for everyone.
Such high processors not directly customers.
So unless you have some access to some institutional facilities where they learn.
But you can use AWS to some extent. I mean, basic ones. But they're not used. Not to do such big signals. On this little thing.
Okay, should we end now?
Okay.
Okay.
Okay. Right.
I think
Thank you, everyone.